Welcome to Build with Nas. My name is Nas. I am the founder of REPL, maintainer of the REPL open core repo, where I publish a lot of text user interface crates and also an async terminal crate. I'm also the author of developerlife.com, which is a developer blog that I've been running for over 2 decades. So for today's live coding video, I wanted to implement a shell from scratch using this terminal async crate that I've written. And the idea here is that this kind of, if you've ever wanted to make a REPL from scratch, like something that you would see in Node or like Python or something along those lines, or even Bash, and then like this kind of shows how we can do that. But instead of doing a synchronous style shell where traditionally readline is a blocking call, so it's when program is expecting user input, it blocks the main thread while it's waiting to read from standard in, and then when enter is pressed, the thread gets unblocked and its buffer is filled with the bytes that the user has typed. So unlike that, we're going to do completely async shell where the readline itself is non-blocking. And so the standard out, there's actually something called a shared writer that's used to instead of standard out, so that all the output itself can be kind of like buffered, so that it doesn't clobber the line editor for readline. So readline in this case also provides a simple line editor where you can program it to have history, or basically you can extend it however you choose. So so with that said, let me start a new project. So oops, is that not it? Oh, cargo new, oops. There we go. Nope. Is that not a thing? Oh. Oops. There we go. Okay. So here we have a new crate that I just created called shell. And the first thing that we're going to need is we are going to need a bunch of crates. So let's see what crates we will need. So there's the main RS. Let's look at cargo toml. Okay. So one of the first ones we'll need is this REPL terminal async. And let's see what version we have. No, that's not right. It's not version 1 yet. It is at version 0.5.6. I just did autocomplete this dependy crate, but oh, now it's doing it. Oh, I don't know how to trigger that. 0? Oh, that's strange. So if I do star, that works, but if I do I don't know how to, like, there was a, anyway, there was like a little pop-up which showed what I wanted. So actually, yeah, this one we want all of them. Actually, I don't know what version of Tokyo is, you know, there's an easier way to do this. I can just do cargo add and then REPL terminal async. That'll automatically get the latest version. Then I can say features full, that'll get the latest version. And I think we also need cross term. We don't need event stream for this example, but we'll just take that. And then I think, what else? Tokyo cross, oh, and need meet. So cargo add meet. Okay. So essentially, the program that we'll build will, let me show an example of what this is going to look like. So let's see. It's going to look something like, example, this one. Yeah. Essentially, we're creating something that's almost exactly this shell async example that's in the REPL terminal async crate. But it's a very complicated example, so I wanted to make a video on just like, how to even think about this and how to make something like this from scratch. So here's the program actually. So if we run this again, and I do -q so we don't see those. Yeah, so that's basically what this thing looks like. So I did Control L, that clears the screen. So here you could see if I do, if I say cwd, as you can see, bash is actually running. So essentially, this is a program that's taking whatever it is that I'm typing, relaying it to a bash process. The bash process executes it, and whatever output comes from the bash process, I'm actually dumping it in the output for my program, my Rust program. So I can do stuff like, I can do some pretty complicated stuff. I can say like message equals hello Nadia, and I can do echo and then message. So this worked because this is actually, there's a bash process that's running for the entire duration, and that's the PID of the bash process. That's the PID of the bash process. So here, if I say cwd, you'll notice it's line 5. So you can see that the bash process is keeping track of which line that particular, just extending that one process. It's almost as if we're writing a script that's being executed one line at a time, which is exactly what's happening. So let's see. Okay, so that's the kind of like the final outcome of this program. So how do we go about building something that will end up look like that when it's finished? So let's write some docs, some comments at the very top. So this is what we're intending to do. So we're going to be using the REPL terminal async crate to provide a prompt, get user input, pass that to the standard in of a bash process, a child process, which is long running, and it runs for the entire duration of this Rust program. And then display the output from the child process in the terminal. So that's essentially the goal. And so let's see. So in order to do that, we need a couple things. We need a mechanism to create the bash process. We need a mechanism to basically a channel that we'll use to shut down the whole thing. So like when because we're going to actually spawn quite a few things, and we want to make it so that the whole thing can be shut down gracefully. And then there's going to be, in addition to the child process, the long-running child process, there's also going to be a task that started whose job it is to monitor the output from the child process, and then use this terminal async thing to dump it to standard out using this shared writer thing. We'll see that in a minute. Then that's one. Then there's got to be some other task which just sits around waiting for the user to type something in the terminal, so that whatever input comes in from the terminal can then be collected and then relayed to this long-running child process. And to do the reading from the terminal, we're going to be using this REPL terminal async crate. To do the writing to the terminal, we're also going to be using the terminal async crate. To run the long-running, to spawn the long-running bash process, we're going to be using Tokyo. So let's do this. So we're going to have we need a broadcast. Nope. We need a broadcast channel for shutdown. We need to create a long. Let's see. Create a long-running bash process using Tokyo. And this is all asynchronous, essentially, this long-running bash process. So you could say child process using Tokyo. And for the specifics of this, I have another video and article that might be useful for folks who are unfamiliar with like Linux TTY and like signals, and like how does dev TTY and standard in and standard out work, what's raw mode, what's align discipline, and so on. It's all in this article on developer life. And also in these 3 videos. So this is we're going to be using this Tokyo process command. Actually, that's the one that we're going to be using Tokyo process command. So that's a similar standard libraries command. It's just that it's async. Then we are going to create a REPL terminal async instance. We're not, and then that's another thing. And then finally, we're going to create 2 tasks. So we're going to create 2 tasks. So one task is, and we're going to join on these. Join on them. So we're going to do a task to monitor the output from the child process, and we're going to do another one to monitor input from the user and relay it to the child process. So that's essentially the goal here. So that's our pseudocode, so to speak. So to create the, let's see, in order to create this, we can do Tokyo broadcast, Tokyo sync, I think. Broadcast, and then we got channel, and it's going to be of capacity 1, and the type is going to be unit type, like, because we just need to send a message to it, and that's pretty much it. And then we have, let's see, okay, so that's that. Then we need let's make a couple of modules to clean up the code, otherwise, because there's a lot of it. So let's do this. We're gonna create a module to handle the, let's see, we're going to create the child process. So let's create a module for that. So let's do this. We can say mod child process constructor. So this is going to, let's do this, use super. So this is going to actually create the child process that we're going to be using. So we can do something like, let's create the function first, and then we'll use it. So let's say that we want to make a function called, actually let's define this first. Say pub struct child process handle. So this is something that will be returned by the function to the caller after the child process has been created. So basically that's the whole thing stubbed out, and then we can actually call this here. Can say let child process handle. There we go. So obviously it doesn't do anything, but so one thing we want to do is pass in, let's say the what program we want to run. So here we can say program, or think of it as a program or external command, like however, because we're going to be passing this to the Tokyo. So let's go look at Tokyo. We have, what is this called? Command. So we can, there it is. So program. Okay, so it is actually program. So we're just passing it program, and then here what we're going to do is we're going to say, we're going to create a command. So we're going to say Tokyo process new using this program, and then we're going to pipe the standard in, standard out, and standard error. That means that we are completely containing this child process. It won't interact with the terminal or whatever process that's spawning it, and that is on purpose. And this, because I'm using niet, I can do this. So if that fails, we error out, and then here we can say net result, and that will be wrapped in OK. This is different. Okay, useful macro that I have. I don't know why it never imports it. This is very strange. This is from REPL. Actually, use I think it's REPL RS utils core. Okay. Oh, it's because it's not added yet. So REPL rs utils core. There we go. That should take care of that. And so here we have, oops, there we go. Okay, so we're just returning a child process handle. So so far so good. And this one we can just put a question mark, and I think we have to do the same thing into diagnostic. Why is into diagnostic? Oh, right. This main function needs to return niet result. This is so that the niet default report handler can kick in. And here we just say okay. All right, cool. Now we can put yeah, there we go. Child process constructor is create child process. Actually, let's say create. I don't know why we need to say create child process constructor. Say new. There we go. So bash, and so I think this handles it, and here we can put that there. Okay. And this goes along with the main function. So I think, yeah, child process handle. So we get our child process handle. Okay, so now we've piped our basically programmatically redirected standard in, standard out, standard error of this child process. And then we have to take it and put it in variables and then return it. So we have to do something like this. This is standard out equals take, but instead of unwrap, we're just going to do, let's see, does it do diagnostic? No, it won't, because, yep, I think because the error that's returned is not a, it's like there's a standard, like, let's see, there's standard Rust error, and there's like two of them. Yeah, this one, the result and the IO. Where's this? Standard error, yeah. There's the standard IO error, which has a bunch of error kinds, and then there's the standard error, which does not have this trait. And this one depends on the other one. So this is a little bit confusing. Yeah, see, this result is T of error, and this is that error. And then this has error kind. So so the niet, I think this, let's see what kind of error this is returning. This is returning option, oh, that's an option. Oh, so that's not even, that's why we couldn't do into diagnostic, because it's an option, it's not even an error. So no, it's not that, it's one of these. Sometimes when into diagnostic doesn't work, it's because I can't remember right now. It's either the error is one of these or one of those, and into diagnostic works well for one but not the other. So, but anyway, this is an option anyway. So so now we're going to say once we take it, if there's any problems, we can just, because let's see, so this is an option, and so if there is any problems, we can say okay. Let's see, so if we get null value, so we can say option, because otherwise returns option B, so this one will be, I think it's or else. What's the difference? I can never remember, like, what's the difference between or else? Or else. Oh, it's a, or else is a function. And or is, oh, option B. Oh, I think we want or else. So we're going to do or else. And we're going to do basically yet and something like that. Let's see what else. Oh, that's also returning a interesting. So if I do question mark won't work. Oh, so what if we just convert it to? Yeah, let's do this. So let's convert it to a OK. So basically, we're turning the option into a result, and we're saying this is a bit of a mess, but this should work. And here we can just say me at macro something. Yeah, okay, that should work. Okay, so what's happening here is that notice that it's no longer an option. So what we're saying is that take returns an option, convert the option into a result. If that's okay, then just take whatever that was, in the OK variant of result, which is this thing. We're just saying take whatever's in the OK variant of result, which is of t, and return that, which is child standard out. We're saying otherwise, if that's not the case, then run this closure, and then this closure returns this error, and because we put a question mark at the end of it, it basically bails. So if I take out the question mark, notice it's now wrapped in a result. And because this is wrapped in a result and that's also a result, this question mark will work. So there we go. A bit of a, not that clean, but it works. So let's do this. That's standard in. We want the same thing. And for standard error, we literally want the same thing. So far, so good. So now we need, in this child process handle, a couple of fields. We want, let's see, actually a couple of things. We want the standard out, standard error. And notice that these are the standard libraries. These are from the standard library. They're not from Tokyo. So, and notice this is also standard library, not from Tokyo, even though we're using command from Tokyo. It's kind of cool. So I think we also need a PID. So we can do PID is, I think PID is U32, yeah. And let's see, we're going to do, let's get a PID. Let PID equals like that. So we can say PID standard in, standard out, standard error. And let's see, does that take care of it? Oh, oops. We can do the same thing here. We can say, let's see, okay, or else, and okay, so now we have PID, standard in, standard out, standard error. Why is this red? Oh, oops. That's because this type is Tokyo process. I was wrong. Sorry, this is the standard library, and this is the Tokyo. So you know what? Let's go ahead and make it explicit. So this will be Tokyo process. That's right. The child standard out, child standard error, child, whatever the prefix of the child, that doesn't exist in the standard library. These are in the Tokyo crate. This is from the standard library. Sorry about the confusion. Okay, so that works. EA type system. And I think another thing we need is this the child itself, just in case we need that. Let's return that as well. So, because the job of this thing is just to create it, and then we can do whatever we need with the things that we've returned. So this is the child handle, and we can do like that. There we go. So we got the PID. We got the child, and we got all the standard in, standard out. Worked out nicely. So that takes care of this one. Don't know what, let's just make it pubs to make these error warnings go away. Okay. So far, so good, I think. Let's see. Okay, that's so I think the next, yeah, so now we have this child process handled. Actually, we can destructure it so that we can get all the things that we need out of it. So we can say child process handle, and this I think we need to import, so we can just say, can this auto-complete it? Yes. Oh, that's fantastic. So there we go. So now that completes like the first part where we have the we created the child process that spawned bash, and then we can continue with the other 3 things we have to do. So the next step is to create the REPL terminal async instance that we see here. So let's do that. I think first thing we'll need is let's make a module for this, just like we did the other one. So we'll say pub module. Let's see, terminal async constructor, and then I think we have. Oh, actually, we should probably also do this. Create a new struct to return, which is we should probably do something like this: struct terminal async handle, and actually that's right, whatever that did, yeah, that's what we're going to end up returning. So what we'll have is a result with terminal async handle, and then here we can say terminal async handle, and this is both actually to-dos. This one is also to do. Okay, that's cool. So here, I think we're going to do this in 2 pieces. The first piece is going to be, we're going to make a prompt. So here, if we look at the terminal async, where is it? The first thing is there's a try new, and we need to give it a prompt. So actually, I'm going to receive a PID here because let's do this U32. So here I can say let something along these lines where it's I'm just destructuring what comes back, and then this is terminal async, and this is shared writer, and shared writer, and this is terminal async. Okay. Oops. There we go. And it's easier if you do it right the first time. Okay. So this one is, we're going to create a new constructor, give it a PID, and the first thing we need to do is we need a prompt. So let's just make a prompt. I mean, we're just gonna, this is just for now. And then we need to create a terminal async, and this is actually using a try new, and we're gonna turn the prompt I think as stir, and I think this needs to be an async function, pretty sure, yeah. And I think this, oh, this is already async. Let's see, believe this has to be awaited, so we can do await, yeah, okay. And we do terminal async try new prompt as string, and then we gotta await this as well, and then that gives us an option, which let's basically we can do something like this. Let's and then if else, basically we do like this. We just say yeah, or in other words, fail. This is basically another way of doing the same thing. So here we just say that we're going to try and get a terminal async out of this thing, and for whatever reason, if we can't get it, then You can even do like this actually if we don't want the question marks. So we can do like this if this is easier to read. I'm not really sure. Something along these lines where it's like, okay, if we're able to get the terminal async, then you know, we get it. Otherwise, just return. And then here we can just return the terminal async. And actually, we also need a shared writer, so we can say shared writer equals terminal async. Actually, there is a method for this. We don't need to do this. It's just called, I think it's get shared writer. No, colon shared writer. Yeah. So, and then here we can just say shared writer. That should just work. Yeah, there we go. So this is a bit cleaner. So the prompt, I actually want a better prompt because I would like to see the PID in colorized. So one easy way to do this is we can just do something like this, where now with we get a colorized prompt where the PID is magenta. I'm sorry, the PID is blue and everything else around it is yeah, magenta and dark gray. So something like this. Actually, what we should do is probably give a space here. There we go. This will be a nicer prompt. Okay. So that gives us we now have this this part done and this part done. The next two things we got to do is we have to create a task to monitor the output from the bash process, and we have to create a task which gets input from the user from the current process, this process, and then relays it to the child process. So those are the next two items. So let's create the these two tasks. So in order to do that, I'm going to just do a Tokyo join. So I'm like writing out these functions first before actually writing it how they're going to be used before actually implementing them. So let's see, we have new thread, and here we're going to have like current thread. Yeah, that makes sense. So here we have monitor child process. Actually, should be spawn. Actually, spawn monitor child output. Yeah. So basically, spawn something to monitor the child output, and then when there is output, go ahead and dump it to the shared writer, which is a proxy for standard out, but it's async friendly. And then the other task is to enter event loop that we're going to use to like this. So we're going to monitor the user input from the current process using this terminal async. There's a function, where is it? Get readline event. And then as the user types things, we're going to take the string that we get from the user. We're going to see if it's exit. If it is exit, we shut the application down, kill the child process. Otherwise, if it's a not exit command, then we hand it to the bash child process to execute. And then whenever the bash child process does something, it'll dump it to standard out using this task. And here we're using the standard in from this child process to actually, whatever we take from the read line, we're going to write into the standard in of the child process. So it's a lot of like plumbing that's happening between here and there. So now let's first create this module called spawn, this one. Let's do this, do pub, and yeah, use super, and then let's stub out this function. I think it's going to be let's see. Actually, that's a module, so we can say spawn. So spawn, is it spawn? Yeah, I guess we'll use spawn twice. Why not? So here we're going to have function async spawn, and then here we're going to do something. Actually, let me just stub this out just so we get rid of these red lines. Actually, let's see if this worked. We're just going to put some to-dos here because I don't think any of this is right. So this is going to be to-do, and that's definitely not right. So here we're going to return, the spawn is going to return a Tokyo task join handle with a unit, generic over unit, so that works, and that is what's being joined here. And so this is not right. This needs to be a Tokyo spawn, something along these lines, but let's just get rid of this. There we go. Something along these lines, yeah. And then what we're going to do is, let's see, Tokyo, so actually let's just put it to do here. Okay. I just want to make the compiler errors go away before we proceed, and then let's do another one. So there's going to be mod pub mod this thing and something like that. So just do to do, yeah, whatever. And yeah, that got the compiler errors to go away. So that's our structure. So we're gonna spawn a task to monitor child output. Maybe we could just call it monitor child output. And here we're gonna do monitor user input. We're not spawning anything. So yeah, so let's implement this one so we can see what's happening. So I think there's 3 branches that we need here. The first one is going to be what happened. Let's do this. So let shutdown receiver is actually shut down. Oh, that's not right. Let's look at this. Actually, that was correct. We could just do it that way. That's not a bad idea. I mean, technically, we could just pass the shutdown sender down, but yeah, this works. Okay, we just send the shutdown sender subscribe. Basically, is the shutdown receiver. That's what that is. So here we say if shutdown receiver, basically if let's see. Oh, actually, this needs to be a Tokyo select because there's going to be multiple branches. So Tokyo select. Then we say shutdown receiver. Yeah. And then you break. If we get something, and this is the. Let's see. This is the branch for monitoring the shutdown signal. Because any part of the system can shut down the whole system. So this is what that is. This is cancel safe, by the way. So if you are curious about cancel safety, I have a video on cancel safety here, which might be worth taking a look at. And there's also another article on here for no, that's not it. Where is it? This one. Yeah, this is also a good article if you're curious about these cancel safety and stuff. But this one is the main video for that. Okay, so where were we? So we had let's see, the shutdown receiver branch. Then we have 2 more branches actually. This is the branch for standard out, and then we also have a branch for standard error. So the way this works is we go result line equals, and then we go standard out, something along these lines. And we're going to clean it up actually. Let's see. Let's see, where is it? Yeah, this one. There we go. So we have monitor standard out from child process. That works. And then, so this means that we are reading from the standard out of the child process, and this is like if it's not an error. So then what we're going to do is that we're going to simplify it quite a bit actually. We're going to do something like this. If it's okay, and then we're going to get the line and colorize it. So we're going to say line to string and then green, and then we're going to write it to actually that works too, but there's an easier way to do this, just that. So we're just writing it to shared writer, and this works because we brought in these things, these traits. So let's see. Okay, and then what happens if there's a problem? Then what we're going to do is we're going to say we're just going to send the oops. Oh, actually, you know what? This is not going to work because I need both the sender and the receiver. So that was an interesting idea that didn't really work. So let's try this. This is actually one of the reasons why I even like shutdown sender, because you can do this. And it gives so much more flexibility than either sending the receiver. I mean, just the receiver, just the sender. What am I saying? It gives more flexibility than passing down the receiver. Because the sender can be, I can use the sender to get a receiver out of it. And this will be shutdown sender, and that is a sender. Same here actually. And so the first thing we'll need to do is we need to get let mute shutdown receiver, and then this all works, because here here what I need to do is I need to do shutdown sender.send. This is, yeah, and this will trigger a shutdown for the whole system. So that's that. And for the monitor standard error, we do pretty much exactly the same thing. This is actually practically identical, only this one we do standard error, and then standard error is red. That's the only difference. Actually, Tokyo select, that's this branch. I wonder if these should be indented. Oh yeah, they should be indented. There we go. Okay, so we have this working. The spawn part. Let's go back to see where we're at. Okay, so that's so far so good. So now we have the a new green thread spawned, and let's see. I don't think, to be quite honest, I do not think we need to pass these in. These do not need to be mutable. I don't think we're even using child. Yeah, and shutdown sender doesn't need to be mutable, so this cleans up that interface a little bit. Okay, so all we need is a standard out, a standard error, shared writer, and a shutdown sender. And then we start the loop, and then let's say if somebody shut down the program, then we exit this loop. Otherwise, we just read from the child process a standard out, and whatever we get. If it's okay, if it's dumped to standard out, we rewrite it, or we read it and then we write it to the actual standard out, but we colorize it green. If it's coming from standard error, we do the same thing but colorize it red. So, and if something bad happens, we just shut down the whole program. Yeah, as we're reading the standard out or standard error. That's what this is. Okay, cool. So now that that's done, let's go to the next step and the final step, which is this thing. We're going to read from the terminal, and as the user types it, we're going to send it to the child process, the bash process, for it to execute, which will then, this will then be monitoring the output of that child process. So this is where we're at next. Okay, there's just one function left to implement, and that is the start event loop thing. So let's see. The start event loop, let's validate these inputs. We need a standard in, because when the user types something into the terminal async, into the standard in of the current process, this Rust program, we need the child's standard in to write whatever the user typed, relay it to there. Then we need terminal async. We do not need a shared writer, actually. We just need the child, because in case we have to, let's see, I don't think these are mutable. I might put mute everywhere. And here we need the child. There we go. This is because if the user types exit or Control C or Control D, we want to be able to exit the program. That's why we're, we have to do this. So, I mean, we have to pass these. Okay. So first thing we need to do is get the receiver. I think our loop is already there, but now we need a Tokyo select block. And here what we're going to do is, the first branch is going to be, actually this is not exactly right, but let's use this as a starting point. So it's kind of like that. Oops, there we go. So this branch is cancel safe. So if somebody says, hey, the receiver shut down, then we need to break out of this loop. That can happen if something goes awry with this thing. These things. Something happens to the child process. We need to exit. So that's this branch, and the other branch actually is the happy path. So if we say, what has the user typed in? Let's say result read line event, and based on what the users typed in, we want to do different things. So something like that. So basically, it looks something like that. So we go, let's see. So we go, oops. I think I put the wrong thing in the wrong place. Let's see. What is this match? Okay, this match block. Okay. Oh, it's still not. What the heck? That's odd. Something like that. So let's see. Why are these braces not? So, oh, that's odd. Let's see. So if I have a terminal async at readline event, and I have this big match block, what the heck? Okay. why this isn't working. So, okay, so this is the match statement. So there's a Tokyo select, okay. And then here, inside of this match statement, we have, let's see. Okay, I have no idea what happened with those braces. That was weird. Okay, so we're gonna get something from this readline event, and if it's an okay, then we actually look at the event, and the event can be of three types. It can be a line, it can be eoff interrupted, or it can be resized. So if it's a line, we just trim the user input, check to see if the user typed exit, and if they did, then we exit. Here, what we can do is we can just say child kiloweight, and I don't know why it says into diagnostic. That is because we're not. Let's see. Yeah, we don't actually return anything unless we do. Oh, okay. So you know what? Let's do this. So for start event loop, because let's do this. Because we don't spawn anything, we can actually have this return a yet result. And because we can have this return a yet result, we can have at the very end of this, we can have an okay. There we go. So, and then that should just match up right, yeah. And then yet result, but here we can do it like this, I think. Oh, never mind. Let's see. Actually, you know what? This is, so this is an async function, and Tokyo join, let's see. Waits on multiple concurrent branches when they're all complete. So if any one of them, will wait for all branches to complete regardless if anyone completes with an error. Oh, okay. So even if there's an error, this will continue. But it won't exit or anything because I don't think, let's see. A little bit unclear of if that returns an error, this is gonna, no, it looks like it's gonna complete. So if we do try join, then it will, oh, okay. So you know what, I'm just gonna drop this result. This makes no sense. So we're gonna just silently just consume these, there's no need for an okay, and this whole thing can be, yeah, there we go, because we're not returning anything. So that cleans it up a little bit. So we have a check to see if the shutdown receiver got triggered. If so, then we exit this loop. We try to get something from the terminal. If we're able to get that and it's not exit, then we just write it to the standard in of the child process, the bash process. And so this basically relays whatever we've typed to the bash process. And then if Control-C or Control-D happens, then we simply kill the child process, shut down the program, and break out of this loop. And this will also take down this spawn, whatever this monitor child output task is. Finally, if anything goes wrong, it does the same kind of thing as we do here. We just kill the child and shut down the sender. So that should work. Let's do this cargo run. This is promising. Let's see if we can see that PID in the system monitor. That excellent. Look, the bash process started by the Nosmal user. That's me, and that's great. And then now we can say CWD. Excellent. That's red. CW is an error. So bash is saying, okay, that's not good. Oh my goodness, PWD, that works. That's green. Woohoo. And then I keep forgetting bash syntax because I'm a fish user. So let's see, we can do message equals hello Nadia. And then we do echo message. And as you can see, it remembered this variable. It's within scope because we've made a REPL. We've made a REPL for bash. So this particular long-running bash process is going to be around as long as this Rust program is around, and anything that's typed in this terminal is going to be relayed to that bash process, which will then output it. So for example, if I see CWD, it goes line number 6 because it's keeping track of how many lines it's executed, because this is that same long-running bash process with the same PID. So here, if I do exit, it'll exit, which is great. And as you can see, it killed the process. Woohoo! So if I let's say I run it again, and if I say pwd, that works. And if I say control D, that exits. If I say control C, that exits as well. So that actually works. So yay, that is our asynchronous shell. So if you've ever wanted to create your own bash shell, fish shell, node REPL, or any kind of shell or REPL of any kind, then this is a really good starting point. The terminal async create there's a lot of capabilities. If you need new capabilities, let me know by creating an issue or just by going to our Discord and letting me know. There's like a full line editor with history support currently. I don't have auto completions or auto matching for the history or some sort of syntax parser. Those are things that in the future they could be added, or maybe create a way to do that extensively. But yeah, so if you have any ideas on how to, any features you want to see in this, if you want to contribute to this, let me know. Just create an issue in the repo here, and or you can join the Discord, which is here. There's our Discord. So yeah, if you like this video, please give it a thumbs up. Please subscribe to the channel so you get notified for new updates. And if you haven't already in Developer Life, you can sign up for our newsletter. So this is I don't really send out too many newsletters. It's just like every time I create a new article or create a new video, that's when I'll send out a newsletter. And then for feedback, comments, and that Discord channel is really good. So if you have any ideas on new content you want to see, or if you have any questions about any of the existing content, please join the Discord server and let me know. On that note, if that's the end of this video, thank you for watching, and I will see you in the next one.